Hello friends, today I am going to teach you the mole concept. So here we go. Before solving the numerical problems based on the mole concept, we should first know some important terms. The first term is gram atomic mass. Gram atomic mass refers to the amount of a substance whose mass in grams is numerically equal to its atomic mass. Or you can just simply say that the mass of an atom taken in grams. It means if you have taken some amount of substance, let it supposed to be X, and if we measure it in grams, then if its mass comes to be equal to the atomic mass of the atom of that element, then we can say that that quantity is the gram atomic mass of the atom of the element. The next term is molar mass. It is the mass of 1 mole of the substance whose SI unit is grams per mole. This term is pretty clear from its definition that it is the mass of 1 mole of that substance whose SI unit is grams per mole. And we can also write the SI unit of this quantity as this. Now we come to the point that what is the mole of a substance? It is just simply that a group of 6.022 into 10 raised to power 23 particles, that can be either atoms, molecules or ions of a substance, that is called a mole of that substance. Means you can just simply say that the group of the number 6.022 into 10 raised to power 23 particles can be said to be the mole of a substance. And we can now say that this number represents the mole of a substance. So here we go for another definition of Avogadro number. The number 6.022 into 10 raised to power 23, which represents a mole. We have already studied that this number represents the mole, which is just the same here. The number 6.022 into 10 raised to power 23, which represents a mole, is known as Avogadro number, and this number is represented by the capital alphabetic letter L. And now we are in a position to study some more basic principles for solving the numericals based on the mole concept. The first is 1 mole of atoms is equal to 6.022 into 10 raised to power 23 atoms, and 1 mole of atoms is also equal to gram atomic mass of the atom of that element. Now another is done. Gram atomic mass is also equal to 6.022 into 10 raised to power 23 atoms. You can take screenshot of this page layout. The explanation of these principles is quite simple, that if you look on the first one, 1 mole of atom is equal to 6.022 into 10 raised to power 23 atoms. We can say that 1 mole of atoms consists of 6.022 into 10 raised to power 23 atoms, whereas on the same time 1 mole of atom is also equal to the gram atomic mass of the atom of that element, and gram atomic mass is equal to 6.022 into 10 raised to power 23 atoms. So for example of this is, if we take the gram atomic mass of the atom of some element, it will contain this amount of atoms. We take an example. We take the example of oxygen, which means the one atom of oxygen. Firstly, the atomic number of oxygen is 8, and its atomic mass is 16 units. Now from this relation we can say that the gram atomic mass is equals to this number of atoms. So we can say that the gram atomic mass of oxygen, which is 16, would contain 6.022 into 10 raised to power 23 atoms in its given atomic mass. And for finding another relation, we can say that the gram atomic mass, which is of oxygen 16 here, 16 grams, 16 units, it will consist of 1 mole of atoms, and at the same time that 1 mole of atom would consist of 6.022 into 10 raised to power 23 atoms, which we have already studied in this relation.